Okay, right now we are live and everybody can watch us. By everybody, I mean at the moment 24 people. It will be more during the talk, and after the talk is finished, more people will watch it. So thanks everybody for coming to the session. Thank you, Marc, Kathrin, and Daniel for being a part of this meetup. It's a pleasure to have you with the Munich community. This time online and remote, but we definitely hope to greet you when the pandemic situation is better in Munich, maybe with a beer during the Oktoberfest, who knows. So let's see if, well, folks, you're here already on YouTube, so you've probably seen our Twitter or our meetup.com website. We will have today Daniel Mather from Novatec. He will be talking about input validation with Kotlin Multiplatform. Marc Reichelt from Iteratec. He will be talking about Kotlin Companion, the power of IntelliJ IDEA. And last but not least, Kathrin Petrova from JetBrains, who will be talking about it's time for Kotlin Multiplatform Mobile. Remember, folks, if you have any question, you can post it on the YouTube channel. We'll be able to read it after the session is over, and our speakers will make the best to answer your questions and any doubt you will have. If you are working with anything regarding Kotlin, if you have any side project, you're doing anything at work, and that you would like to share with us, please contact us, and we would love to host you in an upcoming version. We're a very friendly community, and we love to hear from what our members are doing and chat with them and grow together and learn from each other. So without further delay, Daniel, you go first. So it will be your turn. I'll add your stream, and I will slowly remove Marc and Kate and myself. Daniel, the stage is all yours. Enjoy it, and people enjoy as well the session with Daniel.
All right, thanks, Enrique. I'm very happy to talk to you about input validation with Kotlin Multiplatform today. Who am I? I'm Daniel Mather. I'm from Stuttgart, Germany, and I work as a consultant at Novatec Consulting. My day job is basically agile software development, and I added some technologies I'm working with and frameworks. Like I'm a classical Java Spring developer, lately using Kotlin since about like 1.5 to 2 years now. I'm something you would probably call full stack, although I don't really like that title myself. But I'm also working with Angular, for example, or React a little bit, but the technologies here are the ones I'm using the most. And I'm also a security professional, I would say. I'm a member of the OWASP, and I work a lot with OAuth and OpenID Connect and web security in general. So basically a lot to do, very many exciting topics. You can follow me on Twitter as well. It's Secure Coder is my handle. I don't know how I got so lucky and got that one still, was still available. So I got that one. And you can also check out my GitHub repos on Daniel Mather. All right, so I want to talk a little bit about user input validation from a developer's standpoint. It's something we all have to deal with. Basically, all user input is evil. By standard, you should always treat user input as evil, because users do stuff like that. You create a form. It's a basic contact form where you enter your name and your phone number, and what users do is they put random stuff or stuff that's not gonna be valid in there. So what we have to do as developers, we have to validate what comes into our UIs, our backends, our databases. And if you do user input validation in the front end, it's usually serves for a better user experience, because the user gets told, okay, this phone number. It's not a phone number, but this phone number is too short. You should have at least minimum 5 characters, for example. This is a demo, by the way, so that's not a real validation. You would do this differently, obviously. But yeah, generally, validating user input in the front end is better for the user experience. You would write it as such. This is an Angular native validator for reactive forms. This would check against a regular expression and return a control that you could use inside a form, and it would return null if it's valid, for example, or return an error value. But you also, of course, cannot only do user input validation in the front end, because there might be applications or even users with a valid token can contact your API directly, your backend service. So you also have to do backend input validation, of course. This is mostly for security reasons, but also to ensure your business logic is correct, that you do not store stuff like this, like, for example, test as a valid phone number. And in the backend, you would do it like that, for example. That's a Kotlin data class, defines a phone number, uses some input value here, a string, for example, test, and then in the init function, checks if the value matches a certain pattern, for example, regular expression pattern. And if it doesn't, then it throws an error and tells us, okay, only digits are allowed. This is a little bit simpler than that, but we don't have to give instant feedback to the user while they're typing in the backend, obviously. Okay, so you have 2 different technology stacks now. You have a front-end technology stack written in JavaScript or TypeScript, and you essentially do the same thing. You want to ensure that the user cannot enter stupid stuff that might be even security relevant. For example, if you put injection characters there, that you can do security related stuff with. So how can we be type safe across the entire application front end and back end? Because if something changes, like business, for example, says, okay, we want to limit this to, I don't know, 20 characters phone number, then you would need to go to your Kotlin code in the back end, put it in here, and also put it in the front end, and also in the front end have it valid there, and the validation should be in sync, right? Because if the front end validation validates differently, then the user gets told everything is okay, and they send the form, and your backend says, no, it's not. And then you would need to handle that error again. And that might lead to inconsistent behavior, which is always something we should avoid. And same way the other way around. Like if you validated something in the front end and didn't do that in the back end, then, wait, I just told that, I don't know. So if you validated something in the back end and not in the front end, oops, I clicked, sorry. Let me, then you would essentially also have it out of sync, and which would lead to inconsistent behavior of your application. So how can we solve this? There's Kotlin Multiplatform. Most people, if you've heard about it, and there will be a talk later by Kate, is about Kotlin Multiplatform Mobile, used by mobile developers, where you can share code between an Android and an iOS code base, which is an awesome feature, obviously. Solves a lot of problems for developing for multi platforms. But Kotlin Multiplatform can also have different targets. Like you can also create a client-server application with it that targets the Java virtual machine, and also compiles to JavaScript. And also native targets like Linux, Mac OS, Windows. You can pretty much compile Kotlin to any platform, pretty much. And what I'll be focusing on will be this part, compiling Kotlin code to JVM and JavaScript. Be aware that if you're doing such stuff to get the user input validation in sync, for example, that multi-platform projects currently are still in alpha, and this you might need to expect breaking changes. It's a pretty new technology, and I like it a lot, but you should probably be a little careful if you want to run it in production somewhere. But I'm sure maybe Kate can tell you more about the current state, as she's a developer with JetBrains. So yeah, let's code. Let's do something. Enough talk. Show me the code. So I got IntelliJ here. This is a backend application written in Kotlin. And I'm having the Gradle build script open here, and it's pretty basic. It's pretty short, pretty concise, pretty basic. So I'm just using the Kotlin Multiplatform plugin here. REST is pretty standard, and I'm telling it that I'm having a JVM target and also a JavaScript target for the browser. I can also, or I should, define source sets, like where my source code is living at. And currently, I'm only using a common module for both platforms. But I could also add like a JS main or JVM main or whatever. And but yeah, for this demo, I'm trying to keep it really short. And so that's that. And then I only have this one file here for this demo. It's called phone number. And what I have in there is a data class, pretty standard also, that takes some value, as I shown before in the screenshot there. And in the init function, it checks if the value I enter in here is not blank. And if it is, it throws an error, phone number cannot be blank. And also, I'm validating the length, and I think this is pretty nice. It's a nice way to do object instantiation. Everybody can read it. You don't have to be Kotlin specific to know what's going on. So yeah, this is fully runnable as a backend application. Nothing special so far. But how can I make use of this logic I put in here to use in a front-end application? So here's my front-end application. It's an Angular app. Let me run this real quick. ng-serve. Also, it's a pretty standard Angular application. I put everything inside app component here. Not much to talk about, actually. It's a standard ng on init, and I have a form group there, and with two fields, a name field and the phone number field, two form controls that look like this. So this is the name field, and this is the phone number field. And you can already see it says it's required, but that's still nothing too special, because I'm telling it here in the native Angular validators that those two fields should be required when sending the form. So yeah, how do I get this logic that I just wrote in the Kotlin code here inside my front-end application, because right now I would need to write it by hand. So what I did is I built a little build script, which essentially is nothing too special. It just says, okay, build this Kotlin code here, and use the generated JavaScript file here with the target browser, and put that inside an NPM module structure. So I'm going to do that. Okay, it's just runs the Gradle build and copies the JavaScript that you can find here in the build folder somewhere down here, and puts it inside an NPM module and places this inside my node modules. So if I search for phone number validator, I can find that module there with the compiled JavaScript code. Generated by Kotlin Multiplatform. It looks a little bit gibberish, but nevertheless, it runs. And you can already see, like, it looks like that. If it's blank, then throw a message, phone number cannot be blank. So what it does now, if I enter my name, for example, and would start typing here, it tells me phone number too short, minimum 5 needed, which is never written anywhere in the Angular code. You can find it nowhere. It's really generated. And if you don't believe me, I added another constraint here that matches only digits are allowed, because what I can do right now is, for example, this, I can enter stuff like, and even make it long enough, like, for example, like testing, hit OK, and it accepts my contact and says, okay, name Daniel, phone number is testing. And I would say, okay, this is not valid. I don't want that. So I go back to my code, go to the Kotlin code, and I prepared this already, so I don't have to type it out live, and add another constraint in the backend, require that the value matches this regex pattern that only allows digits. I know this is not a right validation to do phone number validation, but for demo purposes, I want to try. I tried to keep it simple and not have the regex pattern too complicated. So I'm running my build script again. By the way, I could show you the build script also, so you believe me that it's not a major complicated thing. Oh wait, I can't find it right now. It lives a folder. Let's look into this. I'm not sure if you can see it properly, but what it does, it just runs Gradle. Where is it? Okay, so it runs a Gradle build and then copies everything that is inside the build.js input validation folder and copies it to the front end. You could do this with and proper NPM packaging, probably a little smoother, a little nicer, but I didn't have time to do that properly. But shouldn't be too much of a deal. So anyway, I'm going to run the build script again. It's generating JavaScript sources again, and it automatically copied it over to the Angular app. And because I have hot reload on, it should actually already work. So if I enter tester now, it tells me only digits are allowed. And I didn't even touch a single line of Angular code there. So it's like magic. Okay, so if I enter something valid there, I can submit the form again. And by the way, I have the console open here to show you some console logs that the Angular application actually uses. So this is the console log you're seeing on the right side, that the Angular app actually uses the phone number validator from the Kotlin backend. There's not much to do there either. It's basically just defining, okay, I want to have a phone number validator that gets a abstract control. It's pretty standard in Angular. And if it has a value, then it tries to instantiate a new phone number. So I import the phone number exported by the Kotlin backend, and I just try to instantiate a new instance of that. And because the validation logic is exported, it fails. And if it fails, it prints the error message to my console. As you can see here, if it's an error, it tells me only digits are allowed. All right, so that's the magic I wanted to talk about today. I think we're still good in time. And let me get back to the presentation there. Okay, so some closing notes, possible improvements. You might have seen that I used a single module build in Kotlin. So as of right now, everything would be compiled to JavaScript, my entire Kotlin application. And we don't really want that. So what I could do in the future, what we could do is to have a models folder or a models module, and only the models with their validation logic, like the business logic pretty much, is cross-compiled to JavaScript, and everything else is not. So we would only have the models in the front end for usage, because we don't need the API packages and everything. We don't need that. And what I also need to do is I got to replace the build script with proper NPM packaging that exports the types and everything, and also adds a version to the code, so you always know what to depend on. And I'm really hoping that I could tell you about the awesome features that Kotlin Multiplatform provides, besides the stuff that you've probably seen before, like mobile, for example. And if you want to get your hands dirty yourself, you can always go to the Kotlin hands-on page here. They have different apps and tutorials and stuff, and you can always go to this build a full stack web application with Kotlin Multiplatform, and it's an awesome demo on how this works. It will be explained in further details, and they're building a shopping list here with a full-fledged front end that lets you add stuff. So if you don't have a private shopping list app yet, go write your own if you don't have one that you like. And I think that's it from my side. Thank you for your attention. Okay. Are there any questions? Let me,
So if you folks have any question and would like to check it with Daniel, there has been some discussion here on the thread on Kotlin Multiplatform. So Ljubomir has one question.
Sorry, who got a question? I'm reading through the chat right now. Oh, okay. mixed up in the web front end in terms of size. What exactly do you mean by size? Like bundle size, or? I'm not really. I haven't really had the time or the focus to look into that. Like the size of the bundle, actually, if I interpret that correctly. So sorry, I can't give you any good answer to that, I guess. But as I mentioned, it's all still in alpha state, so there are probably going to be some more improvements on that if that's an issue. Maybe Kate knows something about it. I just tried to come up with a good demo, what you can do with it. Yeah. So sorry, I can't really give you a great answer to that. Any more questions? Has anyone tried out Kotlin JS for React so far? I haven't. But compiling, I didn't specify that I wanted as a Angular app or an Angular library. So maybe it's framework agnostic. I didn't use any framework for the backend other than Kotlin standard either. So and it has worked. So maybe it works with React, but I tried to focus on Angular. But basically, it's object instantiation, and maybe you can use that in React also. Try it out. Try it out and give me feedback. Front-end validation is preferred. Double checking with backend. You always have to check user input in the backend because there might be applications, or even anybody with a modern browser can directly contact your backend through your API, and they could enter everything in your backend without you being able to check that if you don't implement it there. And also for security reasons, because you always need to sanitize user input before you put it inside your database. So you shouldn't trust the front end at all. Validating input in the front end is only for user experience, for having happy users. You know, these applications where there's no front end validation and you enter everything and you hit send, and then everything goes red because it's the answer of the backend, and this is wrong, and this is wrong, and this is wrong, and we're here to build better than that, right? Okay. Have you used this approach in production? I haven't. I don't see any reason why this should not work. So I think it would work. The only thing, I don't think it's a security problem to use this in production. But you might be subjected to change of the multi-platform project, so you can't be really sure of any support or anything by JetBrains if it's not released yet. Okay. Protected applications, Kotlin, JS, React works great. Okay. So you're using, Alexander, you're using Kotlin JS with React, but not Kotlin multi-platform. So you're not writing any backend code with it, right? Okay. Yeah, I guess so, because like Kotlin JS is not the Kotlin multi-platform related. It doesn't have to be related. It can be related, but doesn't have to. Okay, of course. Marc answered this even. Okay. Shared between. Oh, you're using that already? Nice. Awesome. Perfect, Alexander. So this was nothing too new for you. So you're bleeding edge. Wonderful. Okay.
Okay. I think Daniel, maybe we can start moving to Mark. If you folks have any question, I guess Daniel, they can reach out to you on Twitter, right, or check it here on the channel on YouTube if they want to check anything with you. So thank you so much for the session. I think it's always good to hear Kotlin multi-platform experiences firsthand, rather than just reading the theory. So we see how it works for a real product.
No.
Okay, so now our next speaker will be Marc. Hello, Marc. Marc has actually recorded his session. We'll be listening to the pre-recorded version, and Marc will not be like at the same time. But Marc, you'll be on the chat, right? So I guess if they are checking anything, please feel free to write it, and he'll be able to check that out.
Yeah, sure.
Yeah. So Marc will be talking about Kotlin Companion, power of IntelliJ IDEA. So I'll add your video to the stream.
Hello and welcome to my talk on Kotlin.
Let me stop it. And yeah, so Marc, I would say the stage is all yours. I don't know how that works with video, but I guess the stage is all yours, or the stage is all the stage of your MP4 file. And yeah, thank you so much for coming. And as mentioned, folks, feel free to write anything on the YouTube channel.
Yeah, and have fun. See you later. Hello and welcome to my talk on Kotlin's Companion, the power of IntelliJ IDEA. Or more exactly, it's about the power of tools, because Kotlin, the programming language, wouldn't be as powerful as it is without all the tools that IntelliJ provides for you. It makes the development experience so much better, so much easier. My name is Marc. I'm working as a software architect and as a Kotlin trainer at the company Iteratec. And you can reach me on Twitter if you want. We're gonna do a talk on lots of amazing tools and tricks you can do with Kotlin and IntelliJ. Some of the tricks are applicable to many languages, but you can use them with Kotlin to make your editing experience more productive. And a common theme in this talk is that we're going to use the combination Alt-Enter a lot to try out lots of different things. So without further ado, let's get started. For example, in this one, I can add the names to call arguments because because Kotlin has the names. I typed Alt-Enter here. I can add the names here. I can do this here with the speaker class as well. And what's really nice about this is you can, here again, Alt-Enter. You can also search in this dialog and say add names to call arguments. And what's really nice also is if you can see right here, now the code is gonna be a little bit more. You can, of course, always do the formatting, but if you want to have this on separate lines, you can also type Alt-Enter here, put arguments on separate lines, and we're gonna do this here as well. Again, put arguments on separate lines, and all of a sudden your Kotlin code got just much better and easier to read and easier to reason about. Also, if you have any other things, like for example, you want to have insert a main function, for example, you can type main. We're using a feature of IntelliJ which is called live templates here. And if you want a main function like this, you can just type main. If you want a main function with arguments, you can type main A. And if you want to know about all the live templates that you can insert at a particular point on Mac, you can type Command J to see, for example, we can insert an extension function here. And this is really, really powerful. And you're going to see me using this feature with live templates also to insert some code snippets later on. So I'm also using some custom live templates here in this talk. One more note is that if you go on GitHub, this project is actually available on GitHub, and you can see right here that we are in this first file. And so you can just pull the repo and try this out yourself. One more thing in this class. For example, also one other thing which you can do with Alt-Enter is if you have a field in a class, in a body, not in the constructor, you can add the getters and setters. If you're like me and you don't really know the syntax of the get custom getters and setters, you can just type Alt-Enter on a field and say add getter and setter, and there you go. It's really, really amazing what you can do with one simple combination, keyword combination in IntelliJ. So as I showed, we will go to the next file right now, which is example2 vectors. So in this example, we have a data class vector which has the fields x, y, and z, and we have two instances of vector right here. And if you want to destructure, if you want to get all the, let's say we want to get all the fields in a single expression, what you can do is you can type a.val, or you can create a variable, and normally you can say create a single variable which will just do the regular syntax. But if we're going to do this again, there was also some other thing which was replace this occurrence, create a destructuring declaration, and then the IDE will create all these variables for you and destructure the vector in its single components. What's really nice about this is if you type Alt-Enter again, you see a common theme here. We're using Alt-Enter a lot. You can specify all the types of all the variables here at this point. That's also really, really nice. Okay, let's do another example. For example, if lots of the times I don't remember, okay, how is this working exactly? What's really nice is that you can, in IntelliJ IDEA, you can just write the code what you mean. For example, we want to have now an addition function, an operator function on this a plus b. And what's really nice is you can type Alt-Enter here on the plus and just let IntelliJ create this member function for you. You can also choose an extension function if you want. So let's go for a member function right now. Let's call this other vector other. Let's return a vector. And I'm going to use the template talk vector here to actually return a vector. Okay, now we have a method. Now this works. So now if I want to print this, I can run this. And what's really nice also about IntelliJ is, for example, if we have only a single expression in a function, you can convert this into an expression function. No need for doing this manually, just Alt-Enter on the brace here, convert to expression body, and another Alt-Enter on the return type, and you can just remove the explicit type annotation here. So this is just really, really cool. And the other way around works as well. You can specify the return type explicitly, and you can convert this to a block body if you desire. And this is really, really nice because in Kotlin you can, and in the IDE, it helps you to reason about the code, to change the code, like in a really, really fast way. It's amazing that this all works. Let me check if I have something more. What's really nice in IntelliJ IDEA, because Kotlin is a type-safe language, but it can decide the type for you. For example, here in this case, this is going to be a vector. In this case, it's also going to be a vector here as well. In one of the older versions of IntelliJ, it was really nice. You could just type Alt-Enter on this variable, and then you could show the types. Right now I can specify the type explicitly, but what was really nice is that you could show and hide the variable types directly. This feature is now under a name which is called inlay hints. And in inlay hints, you can just say, let me type double shift, let's say inlay hints. So I'm gonna go into the settings of the IDE right now, and I jump directly to the inlay hints, and I'm gonna click local variable types. And some people, if you're like me, you have all of these enabled. In this talk, let's just go with this option. And right now you can see, okay, here and here it's really easy because you can directly see from the code that it's a vector. But here, here it's a vector right now, and here also IntelliJ now writes that this is a double right now. And this is also really nice to toggle these inlay hints on. It really gives you a nice editing experience, and you can, for example, if we want to map this to a string, map it point to a string. Okay, let's get rid of the sum right now. Then now we know that this is a list of string. Then we can convert it again to an int again. And we are seeing right now how this type is changing as we are editing the code. So we can directly see what the type inference of Kotlin is doing. Okay, let's go to the next file, I presume. Next file is example3 Java. So let's say we have some Java or JSON or SQL or something. If we have a string in Kotlin or in many other languages, you can just say Alt-Enter on the string, and then you can say inject language, and you can tell IntelliJ what language this is in. So right now it assumes that it's just plain text, but you can tell it, okay, this is actually Java. And what's nice about this is that IntelliJ is now just directly showing the syntax highlighting and everything. You can do this with JSON as well. So for example, here, inject language, JSON, and then you have the editing experience right now. And I'm gonna do this here as well. We're gonna inject the language of regular expression. And then it tells me, okay, if you type Alt-Enter again, you can insert an annotation that now every developer on this project sees that this is a regular expression. And what's nice about regular expressions, for example, I don't know if you know this feature, but I found out about it only recently. But if you have a regular expression, then you can say, okay, check regular expression. And now we have, so here in this case, we have a regular expression for a hex color string. So something like this is not valid. But if I type FFF, or if I type FF00AA, then it knows, okay, that is a valid instance. So that's really, really nice. And one more thing, what's really cool in IntelliJ is that you can create Scratch files. So if I type double shift and I type Scratch file, I can create a new Scratch file, which is just a file in memory, so to speak. And I can say, for example, I want a Scratch file which is JSON, which really comes in handy. So if I go back to the file here, I will copy over the JSON here. And if I found some JSON somewhere, I will just paste it here, and then I can type Command Alt L to format the code, and I can copy paste that back right here. Okay. I think that's it for this file. Let's go to the next one. So this example is about the scoping functions in Kotlin, which are also called also, apply, one, and with. And if you're like me, sometimes you don't really remember, especially at the beginning. It's hard to remember which does what. What's really nice about IntelliJ, why don't you just, edit the code and let you lead by an example? IntelliJ can help you here. For example, if I go to this variable definition here and I tap Alt-Enter, then it says me, okay, you can use apply. So then I can see, okay, this is the way apply works. Then it also suggests me, okay, now this variable you don't need this, you can just inline this. So the code can become like this, and this is something I really enjoy. But let's go back real quick. And if you go on this one, you can also try out also. So now we can see that this is with the parameter it. And then the other options, one and with, they weren't here. But if I go on this one here, I can actually convert all these to a one, or I can convert all of these to a with. And yeah, this is really nice. because it allows you to just see what the code will do and to choose the best possible readable option for you. Okay. One more thing which is really nice. Let's say we don't want to document in page here. We just want to pass the content stream as a parameter. So let's say content stream, PD page content stream. Let's pass this as a parameter. We don't need this variable anymore. Now we can convert this to width. Okay. And what's really nice, okay, right now we have a regular function right here. But if you want to convert the function into an extension function, it's really easy. You can just, on any of these parameters, you can type Alt-Enter, and then you can say, okay, convert this parameter as the receiver of the extension function. And then you can see, okay, now it's the receiver, and it got rid of the parameter. And lots of these things go vice versa. So I can go on this again, and I can say convert receiver to parameter, and it's doing that. It's reversing that change. Yeah, I hope you can use this to make your coding easier and faster. Let's go to the next example. Let's go to enums and sealed classes. What I really like about this editing experience here in Kotlin is the possibility to use string templates. And what's really nice about the IDE, the IDE can convert concatenation to a template for you. So if I type Alt-Enter here and I do this, then it's converted this to a template. I think the other way, I think you can go the other way as well, but let's keep it this way. In this file right here, we are using a when, we are using it on a user creation result, and that right now is an enum. But if you want to convert this enum to a sealed class, it's really easy. You go on the enum, you type Alt-Enter, you say convert to sealed class, and done. It's so easy. And if you want to make this code more readable, let's say here I can import the members of user creation result. Bam, it's made more readable just right there. And also Kotlin says the IDE tells you, okay, you don't have to write the return everywhere here. You can actually lift this out of the when. And it's making the code easier, shorter, and the when is now exhaustive. I think, yeah, okay, we need one more thing. Let's say we have this service method right now here, and we want to give an ID. So for example, this create user function creates the user in the database, and we want to create a parameter which is called ID, and we want to pass it a random UID, for example, here. I think, yeah, right now, so this doesn't work right now, but if I write this manually here, I can say, okay, I got an ID, which is the user ID. Okay, and okay, I need to make this val. I think IntelliJ even tells me to make this val right here, which is really nice. I actually didn't plan for this in the talk, and the reason that it works is just amazing. Now, this is not an object, so we can't do an equal check here anymore. We want to actually check if this is of the type user created, and now with Kotlin smart casts, we can directly access the ID, for example, on this class, which is really nice. Okay, that's about sealed classes and about when and return. Again, the theme here is you can use Alt-Enter lots of times to make your editing experience better. Okay, let's go to the next example. As I said, it's going to be really fast. There's going to be a recording of this talk available, so if I'm going too fast, just go back in the time and you can just stop the video at one point. What's really nice in Kotlin is that the standard lib of Kotlin has all these deprecations. So if you have a function which you shouldn't be using anymore, you can just type Alt-Enter here and replace it with the suggested variant. And what's really nice about this is that you can use this yourself. So let's, for example, say we have an old deprecated login method right here, which has the password here and the username here. So we would like to reverse the order, and we want to use a credentials object right now. I'm actually gonna add a deprecated annotation right here, which has a message and it has a replace with. And this is interesting because now the old deprecated login becomes interactive, and now I can actually type Alt-Enter here and directly let IntelliJ replace the old code with the new code. And as you see, it directly knew, okay, it had to use this value here and this value here. So it's really cool that you can use this in this project. Imagine you have some old function which you have spread all over the code base. What's really nice about this, if I revert this really quick, I think you can type Alt-Enter and you can actually say replace usages of this in the whole project. So imagine having like 500 calls of these and being able to replace all of them directly. But for example, if you're working with other teammates and you can just, give them a deprecation, give them the suggested replacement, and yeah, it's really nice to be working together. Let's go to the next example. Next example is about sequences. Sequences and collections, to be honest. For example, we have collection chain right here. We have a list of letters which sorted descending, then it's sorted, then it's mapped. Okay, this is just an example, of course, but what's really nice about this, if I go on something here, I can actually convert this call chain into a sequence. So in this case, it added a sequence and to list at the end. And actually, if you have lots of if you have a longer call chain, then IntelliJ will automatically suggest to you that this could be converted to a sequence to improve performance, and it's doing basically the same thing. If you type Alt-Enter here. Now it's got to be interesting. So if I type a breakpoint here, I think it's let's go here. Okay, and I'm going to. So the nice thing about Java streams is that you can actually visualize what's happening in the stream with a trace current stream chain, and this is available to Kotlin as well. So if I debug this example, we will right now see in a couple of seconds, we can see that the debugger is launching. And I think you can click this icon here. Yes, that's the traced current stream chain. And then it's actually showing, you can go here, go in flat mode, and you can actually see what this is doing all the time. I'm in presentation mode right now, so I think I can't make this smaller right now. Let's go into split mode again. But what's really nice is that you can see what's happening during the sort and everything, what's happening in the mapping, and then what's the final output. And if you're not in presentation mode, you can see this all at once. So this is, I think, a really, really amazing tool in IntelliJ, and many people just don't know about it. Okay, let's stop this right here again. Let's close this. Okay, and that's for this example. Let's go to the next one. Let's go to coroutines. The editing experience of coroutines is really, really nice. So, for example, let's say I want to add a delay here. So I have a function which is called getAnswer, which returns 42 after waiting a really, really, really long time. So this is from the Hitchhiker's Guide of the Galaxy. And let's add the opt-in for the experimental time here. But now the IDE says to me that I can actually not call this delay function, which is a suspending function, in a non-suspending context. So this is really awesome because it prevents me from accidentally running into this. So I can actually type Alt-Enter here, make think deep suspend, and the same thing here, and the same thing here. I can actually make this suspend, and then then I could run this main function. But we don't have so much time right now during this talk, so let's just skip this. The other way around is also nice. So if I actually removed all of the suspending calls in this function, then IntelliJ tells me that this suspend modifier, I don't actually need it anymore. Let's get rid of this opt-in as well. Okay, and what's really nice, in the recent version of the Kotlin IntelliJ plugin, we now have a coroutine debugger. So this example actually is from the Kotlin website. And if I debug this, let's make a breakpoint here. That was too fast. Okay, let's put a breakpoint here and here. Let's debug this again. So now I'm actually in the debugger, and you can, for example, see the coroutine stack trace here. And what's really nice is that you can actually see the current coroutines running. So if I show this here, we can now see that we are in this coroutine, which is the coroutine that adds the answers here. And if I continue to the next one, I can now see that I'm in this coroutine. If I run this, then I can see that the second coroutine is finished and that I'm actually in the third coroutine. And let's go further. Now all the coroutines are gone and the program is complete. So this coroutine debugger, I haven't used it yet in my production code, but I think it's really amazing to have this tool available to actually debug the code. Also nice is that for every suspending function in your code, in your Kotlin code, you get this nice gutter icon that tells you actually this is a suspending function, which is nice. And the coroutine debugger doesn't only work for just coroutines. I read on the Kotlin documentation that it also works with flows. So that's definitely something to look into. So we are at the last example from our talk, which is multiplatform, and this is just amazing. So I kept the best for last. Actually, just one small trick. So for example, if I have this project right here, and I have some string which references a file, I can just click here with Command and click, and I can just open the editor, open a specific file. So I have a common project right now here. Let's step back real quick, and I have a platform KT. So this file, and this expects a platform name which should return a string. And what's really nice here is that I can click on this and go to the implementation, which is right now in the JVM folder. So in the JVM folder, we are returning the system property, OS name, and OS version. And then we can return the platform name. So in this common module right now, what we're going to do is we are going to add some more targets. So we're going to make this more interesting. I will actually now, so if you are in this build Gradle file, you can actually add the JS target. And you can, I think you can also tell it that this should be in the browser. And let's add all the other targets, for example, macOS and iOS as well. So I have a live template for that right here. So, okay, now I added all the targets, macOS, iOS, and JS. And I will also add this dependency right near for testing. We're going to see what this does later on. So again, so what we just did is we now added macOS and an iOS implementation, so the targets and a JS target with a browser. And now the thing is that Kotlin will tell us, the IDE will tell us that platform name actually has no implementation for iOS, for JS, and for macOS, because we just created these. And when I tried this out, so the tooling of Kotlin multiplatforms got so much better in the last couple of months. It's so amazing, it's so nice. So if you go on the source folder here, and I'm gonna type Command N, and I'm gonna create a new directory, IntelliJ automatically suggests to me which of these I can actually create. So for example, I want to create an iOS main folder. I want to create the JS main Kotlin folders. And we're gonna do this as well for macOS main. And let's also create the common test directory. Okay, and so we have this right now, but we don't have the implementations yet. So we have all these source folders right now, which is nice. But I can actually type Alt-Enter now on this expect function, and I can create the iOS part. And let's go back. So I can go to the implementation. I want to create the JS part. Let's go back to the expect, and I want to create the macOS main part. So you can see that all these are now here. So we can see there's the get platform name here. Let's just rename these really quickly so that they are all called platform. Okay, and now for something really amazing. So if we are in this iOS main folder right now, we can actually use all the tools that are available, all the libraries that are available, and we can use them directly from Kotlin code. So in iOS, there's in UIKit, we can actually call UI device dot current device. And what's really nice about this is actually no Kotlin code available there. That's the native implementation of UI device. So if I command click on this one, and if I go to the declaration, you can see that all of these libraries have been pulled in. All these dependencies have been pulled into our project. And we can see, for example, right here that we have StoreKit 2 times, which is 1 time for the iOS implementation and 1 time for the macOS implementation. And I think this is really amazing to have all of these things available, all of these native implementations available here. This is just an amazing tooling. So let's go really, really quickly about all of these things right now. So I'm gonna do the implementation of all of these really quickly. So let's implement the iOS part. This is here. Let's go to the expect again. Let's go to the implementation of JavaScript. Let's implement JavaScript. Okay, and also here again, as you saw, we can use the native functions that you have available on this platform. So right now we are in the JavaScript world, so we can have access to the window. Let's go to macOS and also implement macOS. So it's going to be a little bit different here. Let's implement macOS. Let's import ns-process info. Okay, and I think I have all the implementations ready to go. And now for something really amazing. So let's say we want to have a test and we want to show all of these. We can actually say, okay, we now want to have a new test class, which is called platform test. Okay, again, I'm not gonna write this here. I prepared this in advance. So let's say we have all of this written here. So now we are importing this platform name, and we are in the common test folder. So we're actually importing the expect function get platform name here. And now if I run this test, I can actually run this on. So I typed shift, I hold shift, and I selected all of these. Now I press enter, and IntelliJ will run all of these things, all of these implementations now for me on all the implementations. So here we can see it on the JVM, and it will actually also start a browser, a headless Chrome browser to run the JavaScript implementation, which I think is really awesome. So this might take a few seconds. Let's wait for it. Okay, here we can see that it actually ran in Chrome headless, but we're gonna see that it's also compiling and running these things on iOS and on macOS, which is really, really cool. And if that's not cool, then I don't know. So for example, let's say, okay, we want to rename this get platform name to get platform description or get platform string, for example. And now I actually renamed this in all of these variants. So in all of these files, it's now renamed to get platform string, as well as in the test. And I think this is just really an amazing tooling right there, and I can't imagine what to do with it in the next couple of years with Kotlin Multiplatform. Okay, let's go back to the thank you. So this has been the talk. I hope you enjoyed it. Thank you for listening. Again, this talk is available on GitHub in github.com/mreichelt Kotlin talk IntelliJ tricks. And if you want to know more about IntelliJ tips and tricks and about keyboard shortcuts and whatnot, I didn't describe all of them in this talk, but if you want to learn more, then go here. And I also created a Kotlin Slack channel, which is called IntelliJ Tricks. So if you want to exchange about all of these tricks, then that's the right place for you. And really hit me up on Twitter. I'm really I'm hoping for your suggestions and for your tips and tricks for the next version of this talk. Thank you. Yeah.
Well, Marc, now we have 2 marks on the screen. Let me remove the second one. So thanks so much for the session. If you folks have any question, I think some people was writing a few things, Lubomir.
Yeah, actually, the question of Lubomir was about the deprecated annotation. So let me share my screen real quick. Okay.
Okay. This one from here, right?
Yeah. And I think his question was about if you can actually use the inject. Can you use the raw string mode with injected code, highlighting into deprecated replace with function? Yes, you can, but it doesn't do what you think it does. So actually, you can press Alt-Enter here, and you can say, okay, you want to have a raw string, so that's fine. And you can also inject the language here. So I can say inject language Kotlin. And now it actually shows the syntax highlighting here, but this is no valid Kotlin code right here, right now, because it doesn't have a function declaration. So it will actually tell me that it expects a top-level declaration. But it will work just fine, I think. So it will show the deprecation here, and I can just replace it with the second one. Yeah, thanks for the question.
Okay, folks, if you have any further question.
Yeah, I think there were some other questions. I think there were some other questions as well, like the awesome tricks. Are these available in the community edition as well? I think all of the things I showed here were available in the community edition. Although I used the ultimate edition because, I mean, these are just amazing tools right here.
Okay.
I think that was it, basically.
Great. Then, Marc, thank you so much again for making the time and having you. We also proved that pre-recorded sessions works really great with this format, right? So definitely something to check out in upcoming meetups. And well, I guess if anybody has any question, they can reach out to you on YouTube or find you out on Twitter, right? You're quite active there, so
yeah. And I will write my Twitter handle in the YouTube comments.
Yeah, that would be great.
Great.
Okay, folks. Then, Marc, thank you so much. And I'll be taking into the stage Kate. Hello, Kate.
Hi. Hi.
Well, last but not least session of today, Kathrin Petrova from JetBrains, who will be talking with us about Kotlin Multiplatform for mobile. So, Kate, thank you so much for making the time and thinking of us, and the stage is all yours.
Thank you. Thank you. Thank you for having me here. Unfortunately, remote, but on the other hand, it's just amazing to have, an ability to be transported to Munich, for example, in just one click and just 1 second. So I may need to warn you that my talk will be definitely longer than 20 minutes. So please take a cup of tea, relax, and let's make our KMM journey together. So in this talk, we are not going to spend much time discussing why you should try to make your applications cross-platform, because don't repeat yourself is already kind of a mantra for most of us, and no matter which sharing scenarios are on the table. Daniel has already shown us how cool it is not to have the same logic written twice. And by the way, Marc, thanks for your amazing tips, and especially, of course, multi-platform ones, because it's also a great bridge from your talk to mine, and I hope mine will be as useful as yours. So let's go. Alex and Anne, they also don't love doing the same job twice, and they're in love with mobile development. So today we will help Anne and Alex to take a journey into the wonderful world of cross-platform mobile development, and we will see how Kotlin Multiplatform Mobile will help them along this way. And one disclaimer, this talk is mostly an intro to development with Kotlin Multiplatform Mobile, or KMM, so it will be most useful for those of you who don't have much experience with this technology. But I hope that experienced KMM users, if we have some here today, would also find something for them. For example, maybe some ideas of how to introduce KMM and explain all its features to their team. So today we will take a look at all the different stages of mobile application development and learn how to use KMM features to optimize them. To make the picture more realistic, we also will discuss possible obstacles you may face if you decide to integrate KMM into your project. And of course, we are going to discuss how to overcome them. And finally, to give you even more inspiration, I will share with you some insights of how KMM adopters are using KMM, because it's quite flexible technology, we will discuss it later, and there are hundreds of ways to cook it. But first things first. To make sure we are all on the same page, let's make things clear and figure out what Kotlin Multiplatform Mobile is. So Kotlin Multiplatform Mobile is an SDK for cross-platform mobile development. It uses the multi-platform capabilities of Kotlin and includes various tools and features designed to make the end-to-end experience of building mobile applications efficient and enjoyable. So KMM allows you to use a single code base for the business logic of iOS and Android apps. You only need to write platform-specific code where it's necessary, for example, to implement a native UI, or when working with some platform-specific APIs. KMM is seamlessly integrated with your mobile project. Shared code written in Kotlin is compiled to JVM bytecode with Kotlin JVM and to native binaries of Kotlin Native. So you can use your KMM business logic modules just like any other regular mobile library. And KMM doesn't impose any restrictions on how you develop your app UI. You can use the most modern UI frameworks you want, for example, SwiftUI for iOS or Jetpack Compose for Android. So KMM equals Kotlin Multiplatform plus the mobile-specific stuff around it. What is the mobile-specific stuff? The best example is the KMM plugin for Android Studio, which allows you to write, test, run, and debug shared code in the same IDE, both on Android and iOS devices. I will show a short demo later. When it comes to cross-platform development, I think it's always a choice. KMM is not the first and not the last technology of that kind. And I want to spend just a moment talking about the variety of options available and compare them a little. Not to select the best, it's the wrong way, but to understand what kind of project KMM is best suited for. For that, let's take a look at the architecture of a standard mobile app. Basically, it consists of several layers: the UI layer, presentation layer, business layer, and data access layer. If we imagine a scale where the bottom point is core and the top point is UI, we can see that the most popular cross-platform approaches are UI-centric. What does it mean? It doesn't mean that you can't write business logic code. Of course you can. It means that the whole ecosystem is focused mainly on developing UI components. But when you decide to write something more complicated than just sending HTTP requests, you maybe will be almost alone in this wild west cross-platform world because of the lack of libraries and practices. However, these technologies allow you to create similar interfaces for your apps very quickly. So this approach, I think, is absolutely justified when you have some simple apps, thin clients, or if you just want to make an MVP to test your product assumptions. It's important to be agile. But when your product starts to grow, the UI quality and responsiveness requirements get stricter usually, and the business logic becomes too complicated for that UI-centric approach. And this is where the business logic-based approach comes in. We already have some well-known players here, such as strategies to have shared C++ or JavaScript code, for example. And as always, they come with different advantages and disadvantages. All core-centric approaches assume having an ability of integration into the existing project, because, well, you need to write the UI part and connect these two parts. So for that kind of approach, your legacy code base is not a blocker anymore. But one of the most harmful disadvantages is the need to add one more additional language to the existing code base, together with its own tooling, ecosystem, and rules. And this doesn't seem like the easiest way to avoid duplicating just some part of your code. But when you could write all your business logic in Kotlin, it's not a problem anymore. So with Kotlin Multiplatform Mobile, Ant and Alex can immediately start sharing business logic between iOS and Android projects in any project without any limitations on the UI development process and in their favorite language, of course. So I think it sounds good. And let's have a closer look at how to develop such kind of applications. How many of you have been thinking about starting a new pet project to try out some new cross-platform approach during last holidays? Alex is no exception. He loves space, so he wants to create a mobile application that will get information about SpaceX launches, store it in a local database, and display it in a list. Well, yes, it's a quite simple application, but as always, it's just the beginning of a big story. So together with Alex, let's go through the development process of a typical mobile application and see how we can use KMM to make it cross-platform. At the first architecture design stage, we need to decide what parts will be shared and what parts will remain native. Let's go back to our architecture diagram. KMM is designed to allow you to share the business and the core layers of your app. When we are creating a new mobile app, we definitely don't want to spend a lot of time thinking about organizing the data layer. It's such a common task, so there should definitely be some building blocks to do it quickly. And KMM provides exactly these building blocks. The ability to use platform-specific APIs along with expect actual pattern allows you to create them without reinventing the wheel. So the Cater HTTP client is a good example of such a block. Like all multi-platform libraries, it provides several artifacts, one with common logic for all platforms and drivers for different platforms, which allows you to use the platform-native capabilities to perform HTTP requests. The other building block we need is Kotlin serialization, which we will use to deserialize JSON responses into objects of entity classes. And the last one is SQL Delight. This will generate Kotlin code from SQL queries to create a type-safe database API, which we'll use to communicate with databases on iOS and Android devices. As a Cater library, besides the core artifact, SQL Delight also provides platform-specific database drivers, one for Android and one for iOS. For the domain layer, let's add a couple of entities. In Alex's case, there should be entities for rockets and launches. And let's also add wrappers for Cater and SQL Delight libraries that will allow us to get the data as business entities and hide some core details. And finally, the entry point to the KMM shared module will be the SpaceX SDK class, a facade over our networking and caching service. It also could be considered as interactor, for example. Now we have the mobile SDK, which could be used in our application. It also can be easily distributed as a separate mobile library to allow our developers to create clients for our web source, for example. This is a very, very simple KMM model architecture, of course, but it's quite enough for LXP process. And of course, you can create more and more layers of abstractions to make your code even cleaner. That's it. The rest to do is just to implement our architecture in pure Kotlin. And with the help of Gradle and Multiplatform Gradle plugin, we will get the needed artifacts for our Android and iOS apps. There are different approaches of how to deploy these artifacts to mobile projects. If you have a monorepo, it's the simplest case because you could just use single Gradle project for both the Android and shared modules. And for iOS, you could manually configure Xcode by linking the generated framework file, or you can use CocoaPod's Gradle plugin to add dependency on the KMM library via a popular iOS dependency management tool. It's named CocoaPods. In the case where you have independent repos for Android and iOS projects, KMM artifacts are built again using Gradle and uploaded to the local or remote repositories, Maven for Android and CocoaPods repository for iOS. So we have figured out that Kotlin multi-platform projects are built using Gradle, and let's now take a look at the build Gradle file of a shared module to better understand the KMM project structure. There are three main parts of any Kotlin multi-platform projects, and we have already mentioned them today. So targets, source sets, and compilations. A target is a part of a build that is responsible for building, obviously testing, packaging the application for a specific platform. Source sets are collections of Kotlin code files along with their resources, dependencies, and language settings. In common source set, you can use only Kotlin stuff. However, to implement the same logic on Android and iOS, you sometimes need to write two platform-specific versions of it, for example, to access data stored on the device. And to handle such cases, Kotlin offers the expect actual mechanism, and Marc has shown us how you can work with it in your IDE and work like a pro with it. So your expect declarations goes to the common main source sets, and the actual implementations go to platform source set, Android main, and iOS main in our case. And this is where you could use any platform dependencies. For example, you can add dependency to OHTTP client for Android and to IF networking library for iOS. A source set can be used in Kotlin compilations for one or more target platforms. And each target can have one or more compilations, for example, for production and for testing purposes. So, in our cross-platform mobile project, we need to declare two targets, Android and iOS. The common dependencies that are used in all targets need to be declared in the common source set. In our case, the Cater, Kotlin X serialization, Cater serialization feature to connect previous both libraries, and the SQLite runtime. We also need to specify dependencies on Cater engines and SQLite drivers because there are many of them, and it's just impossible to determine automatically which of them to use. And one more tricky thing, this tiny iOS declaration hides some tricky KMM model configuration details for the iOS target. The thing is that the iOS simulator and iOS devices currently have different processor architectures. So to be able to run and test our app on both of them, we need to compile our shared code for two targets, not for one. Remember that we use native binaries for iOS target. You don't really need to think about it while you're working on the shared code for your mobile apps, because everything just works out of the box with this tiny declaration. So, configuration is finished, but before we start writing code, let's discuss our app architecture a little bit more. I know that for mobile developers, discussing different architecture is considered to be a hobby. But jokes aside, we've discussed core and business layers. But what about presentation? Do we need to share it or not? We definitely can do this, and there are already many community libraries that allow you to do this and have plenty of examples of their usage. But you need to think carefully. Do your apps look similar enough to have one presenter, view model, or controller, or application state for both of them? And could this change? I let you make the decision for yourself about your apps. And today, I suggest to go with only shared business logic. And after all, it's never too late to do some refactoring and move more layers to the shared module, if you are sure that it's worth it. Our application architecture is now designed, and we know how to configure our project. Let's finally write some code and discover some KMM features. Of course, KMM is seamlessly integrated with Android because you use Kotlin for every part of your project, and you work in the same IDE both for shared code and for platform code. But remember that we are writing shared code for both platforms, not for one. And KMM also provides tight integration with the iOS development process. Thanks to Kotlin native bidirectional interoperability with Objective-C in Swift, you can call Kotlin code from Objective-C or Swift, and you can use iOS libraries from Kotlin. You can integrate KMM modules in a natural way for iOS developers using the CocoaPods dependency manager I've mentioned before. And with the new KMM, not new already, with the KMM Android Studio plugin, you can write, run, test, and debug shared code both on Android and iOS devices, all in Android Studio. Let's take a closer look at these features. Alex created a single function in the SDK class, which returns the list of launches from the database. So we can easily use our KMM module API in Swift. Kotlin's list is mapped to Swift array, so calling this function looks very natural. But before getting the cache data, we need to load it somehow. So we need to make an HTTP request. GetLaunches is a suspending function, so our public GetLaunches function need to be marked as suspending too. There is no such concept in Objective-C Swift, but you and your iOS developer teammates don't need to worry about it. Suspending functions are available as functions with callbacks. So when you have such functions in the generated frameworks header, you can call them from your Swift or Objective-C code and even override them. Our HTTP client can throw an exception during the GetLaunches call. There is a fundamental difference in error handling between Kotlin and Swift. All Kotlin exceptions are unchecked, while Swift has only checked errors. Thus, to make Swift code aware of expected exceptions, Kotlin functions should be marked with a throws annotation, specifying a list of potential exception classes as a parameter of that throws annotation. And now we can handle all exceptions in our completion handler in Swift code. This was just a small example of Swift and Objective-C interoperabilities. It supports all fundamental concepts, and it doesn't require any additional setup. I think that's the best part of it. So it allows you to integrate with KMM modules in iOS projects without a headache. As I mentioned, Kotlin Native also provides integration with the CocoaPods dependency manager, the most popular dependency manager among iOS developers. You can use KMM modules as a CocoaPods dependency, or you can add dependencies on pod libraries, store it locally or in the CocoaPods repository. And the most beautiful thing that you can manage pod dependencies directly in Android Studio, enjoying full coding support. And on the subject of Android Studio, with the KMM plugin, you can create a new KMM project or modules with just a few clicks. And you get integration with your iOS device and simulator directly in Android Studio. With a new Kotlin Multiplatform mobile project wizard, you can create a ready-to-run mobile application project with a shared code base in just a few clicks. This generated project will contain examples of how to connect to platform-specific APIs, how to set up CocoaPods integration I just mentioned, and it also includes basic test coverage. You can use these widgets, for example, to explore the basic KMM features or as a scaffolding tool for your new KMM production applications. I'm sure this wizard will help Alex start developing KMM applications much faster. And the best thing, you don't need to switch IDEs and even have Xcode running to check that your code works correctly on both mobile platforms. You can run and debug your application and test it on the simulator or a device with the predefined run configuration. After writing our code, we need to test it and deploy it, obviously. And I think you'll be glad to hear that there are no big differences in the process, as your shared code is connected like any other regular dependency. One difference, if you want maybe to optimize your manual QA work now, is that because the business logic code is reused and you don't need to test some features on both platforms, and you only need to do it once. So, congratulations! We've designed the architecture of our app, created a project with the KMM plugin wizard. We even have written some code in Kotlin and integrated it into both our iOS and Android apps. You can find the complete project with a step-by-step tutorial at our hands-on portal and use it as a guide to creating your own KMM application. Anne and Alex look really happy, I think, because now they definitely know how to stop duplicating code for mobile platforms, and they've learned that it's definitely time for Kotlin Multiplatform Mobile. And everything sounds great at this stage. But you know, a lot of such talks usually feel like a draw and all story. Everything is easy on the first step, but when you want to create something more complex than just basic examples, then everything becomes not so smooth. Of course, you will meet some obstacles on the way of integrating KMM if your project is rather complex and your team is rather big. But in my experience, it's a common thing for any kind of technology. So based on my experience and the experience of lots of KMM adopters, these are the most popular obstacles the mobile team faces. Some of them are technical, such as JVM and native false differences, Objective-C interoperability issues, and Kotlin native compile time. And as you see, they all related to the native development of Kotlin, and it's quite expectable because Kotlin is originally was JVM-based language, so integration with the Android world is smooth out of the box. You could also face an organizing team challenge, which is more process-like, and it's usually handled when you're integrating new technology into your code base if you're working in a team, if you're working not alone. But forewarned is forearmed. So let's go through these challenges quickly and see how Kotlin team addresses these issues and what you can do to overcome them right now. When we speak about Kotlin multi-platform programming, here is a tricky thing. It's the same and not the same Kotlin simultaneously. It uses different compiler backends under the hood to be able to run Kotlin code both on JVM and on native platforms. That's why the realization and behavior of some things can be different. And the most vivid example here is the memory model realization. It greatly affects the experience of working with concurrency. For example, your code can work perfectly on Android, while you will get invalid mutability exception on iOS. And it can scare you a little bit, especially if you have no idea what is going on under the hood. So how to overcome this challenge? I suggest you first learn some basics at our documentation portal. It's much easier to work with Kotlin native concurrency when you understand how it works. There is a set of articles describes Kotlin native concurrency rules, how to work with them, and also suggests different approaches how to work with concurrent code in KMM projects. One of them is to try to manage concurrency only in the shared code and make calls to the KMM library only from the main thread from iOS and Android code. If you combine this approach with using the concurrency libraries, such as coroutines library, you would avoid the majority of potential problems and everything will work smooth. And one important thing to mention, to use coroutines on multiple threads in native world, currently you need to use special version of the coroutines library. This special version is living in a separate branch of Kotlin X coroutines repository. It may look strange, but it's safe to use it in your projects because it will get continuous support until Kotlin team implements the new Kotlin native memory management model. Because now using multi-threaded coroutines may result in memory leaks sometimes. This can be a problem for very, very complex coroutine scenarios under a load. So the new Kotlin native memory management model is on the roadmap, and the Kotlin team is working really hard and really actively on a solution for this. The next obstacle some users face is some, I would say, unexpected things about how interoperability with Swift and Objective-C works. Some of the usual complaints, for example, how enums and sealed classes are represented in the generated headers, or that there is no default function argument support. And my first advice here, it may sound strange, but to be ready. At a first glance, Kotlin and Swift look very similar, and you expect that you will be able to work with every Kotlin construction in Swift as usual. For example, I was very surprised when I created a companion object with a single function in my Kotlin code, and I didn't find a corresponding class member, static function, in generated Objective-C headers. But then I realized that that's reasonable, because companion objects, they are objects, and they can, for example, implement interfaces. So this doesn't seem correct to unconditionally export all object members as class members. Another example of fundamental differences between Kotlin and Swift is exception handling, which I described earlier. And when you realize these differences, it becomes easier to handle them. If you are using a language feature and there is no such concept in Swift, you simply can create some wrappers in your shared Kotlin code. For example, before Kotlin 1.4, suspend functions weren't supported in Kotlin native Swift interop. But it doesn't mean that you weren't able to use it. You could create a simple wrapper function for them, and since 1.4, the support is built in. And if you don't like the generated Objective-C declarations and you want your code to be more Swifty, you can create a wrapper module Swift using the adapter pattern. Of course, this approach comes with the need of writing some extra code, but your shared module API will look as you want, and other developers may even don't know that they're using a Kotlin library under the hood. So the choice is yours as always. And as you can see, improving exporting Kotlin code to Objective-C, which will also improve Swift through Objective-C interoperability, is one of the goals for the future Kotlin versions. Organizing the team can also be challenging, as software development is definitely a team game, with each critical decision needing to have an approval of all team members. And integrating any cross-platform technology will significantly affect the development process for your mobile application. So before you start integrating Kotlin multi-platform mobile in your project, you'll need to introduce your team to the technology and guide them gently to see that it's worth adopting. On our documentation portal, we have a special article with some recommendations on how to do it. For example, how to get rid of any pre-existing bad feelings, about cross-platform applications, like they're slow, they look terrible, and whatever. And how to provide continuous support for your teammates in an adaptation period. To start using KMM in your team, you need to answer some organization questions from who will be the owner of a shared code, where it will be stored, and how it will be derived to the projects, to what parts of application do we want to share. The main advice from our adopters: integrate KMM gradually, because it allows it. For example, you can start with a small new feature, or by using KMM in the new internal product. This will allow you not to stuck with lots of unanswered questions, and will give you time to make each decision carefully. And a good source of knowledge and inspiration for such kind of decisions is the first-hand experience of KMM production users. On our documentation portal, you can find not only the list of the teams, but also what is important, their stories about how KMM is used in their product and what profits and gains they have experienced since adopting Kotlin multi-platform. We saw what challenges you may face on your way of integrating KMM, but don't be afraid, because Kotlin team is working hard to make KMM users' life better, and you won't be alone. Community have been successfully overcoming these challenges, and I love the fact that they're constantly and actively sharing their experience all the time. Recently, we conducted the first big Kotlin multi-platform survey. And for the last step of our today KMM journey, I want to share with you some insights to give you the full picture of the KMM ecosystem. With the majority of respondents having more than 5 years of development experience, we can conclude that Kotlin multi-platform is interesting to those who have a lot of knowledge in programming. I can't deny that KMM has a steep learning curve. I love this metaphor a lot. Flutter and React Native is a pre-made cakes, and all you need is just go, buy it, and admire the taste. But of course, there is always a risk that you won't like one of the ingredients and or how they go with each other. And KMM is more like cake recipe. You can configure it in the way you want to get something amazing, but you definitely need some cooking skills to do it. Lack of education materials is a huge blocker to start for developers with less experience. And the KMM documentation portal, which I've already mentioned numerous of times, contains a lot of useful information that definitely should help you during the intro period. And that situation is changing, and we can already see that the number of developers with our experience is growing. Kotlin multi-platform is popular choice for creating open source libraries and internal SDKs, but not only. It's trusted more than 40% of respondents to build user-facing applications with shared code. It's a common question. And the most popular question I often asked, is Kotlin multi-platform ready for production? I think this is the next one after the question about could I write Flutter apps in Kotlin? So about production. According to survey results, more than half of our users have already released an application with a shared module or are about to release one in the near future. KMM alpha status is not a blocker for going production, but you need to be ready to spend some time for migrations to the newer versions, because technology is evolving and some changes could be made in order to satisfy users' needs. The majority of users used multi-platform project IDE wizards to get started, and I think you should also give it a try. And my favorite one. KMM was designed to help developers use their business logic between mobile platforms, as we discussed in the beginning. We can see that all that kind of stuff like networking, data serialization, and synchronization logic, some algorithms, are most popular options here. But we also can see that the original purpose is not stopping developers from using KMM for other parts of apps. For example, presentation layer, presenters, view models, and the UI state options. My teammate and I are developing open source sample application. It will be full working application published on App Store and Google Play. We're using Redux-like architecture there, and we're sharing application state in the KMM shared module. I will send all links after the talk. And there are even adapters who are using Kotlin for all code base, so it's 100% shared. They've written a multi-platform library that provides a declarative UI and application screens management in common code. And as far as I know, they even have a production apps based on that library. I think it's more like the unusual way of using KMM, but the main conclusion here is that it's really flexible technology, and you could cook it. You could cook everything based on this cake recipe. I think it was a huge overview of the KMM world. So why it's time for Kotlin multi-platform mobile? KMM is now in alpha and is moving to beta. This means that the Kotlin team is fully committed to improving this technology and helping it evolve. It also a signal that the product will develop quickly. It's really easy to start. You can create a new project in a few clicks or easily integrate a KMM module into your existing project. And in both scenarios, the work can be done with minimal cost and you can always go back to fully native development and use all your Kotlin code for your Android apps. The community is growing fast and you can influence the development of the whole ecosystem by participating in it. And the last question, what's the best way to start? The KMM Developer Portal, as I mentioned, is your trusted resource when you're working with KMM. You will find content for all levels of expertise, from tutorials to get you started to more advanced development topics. It contains useful information about common tasks like organizing networking and data storage layers, and even organizing the development process around KMM. Looking for new ideas about benefits of using KMM in your application? I suggest you learning from a first-hand experience of a variety of teams, for example, VMware, Quizlet, and Yandex, who are already using KMM in their products in the case study section. And of course, try the new KMM plugin. With the wizards and with the iOS integration, you can create a new KMM project in a few clicks and start exploring all the KMM new features. Thanks for your time and have a nice Kotlin, multi-platform and mobile.
Thank you so much, Kate, for your time. I think it's definitely been a very intense session on KMP for mobile. Folks, is there any question you would like to ask Kate?
And now I will spend time reading all the comments because I was focused on the slides.
Yeah. I think there has been a few conversations here between Juhani and Lubomir about the tooling and how the tooling looks like for KMP or their impression on it. Juhani complains that does not seem to be very stable. Lubomir mentions that every time he's building iOS artifacts, he needs to make a complete clean to get the autocompletion and the environment back to normal.
I think these all are known issues, and currently, as KMM is one of the primary focuses of Kotlin team, of course, the stability problem, the stability issue is on the track, and I think the main advice is to have the latest version of Kotlin plugin, because as far as I know, yes, these problems definitely exist, but we receive fixes all the time. So please update to the latest version.
I think that's definitely with Kotlin is a good idea, right? Trying to keep the plugin and the Kotlin version on the latest stable state. Unfortunately, releases more often than Java. We don't have to wait a few years until the next version is ready. Lubomir has one question. Just to repeat, because it might get lost in the discussion above, I have a question. Similarly to how there are best practices for writing Kotlin code for seamless interoperability with Java, we need some guide and examples on how to write Kotlin code for our iOS colleagues to use.
Yeah, that's a perfect request, and I can share that in our team that contains technical writers, developer advocates, our product manager, the issue named Objective-C Swift Interop story, it contains features and documentation tutorials, is the top item in the backlog. So you're definitely right, we need these guides, and currently I agree with you, Objective-C Interop is covered very poorly in the documentation. So I just can say we're working on it, and I'm happy to hear that our understanding of the priorities of the pains is the same is from our users. So thanks for your feedback and for your request.
So Johanny has another question for someone who has been evaluating Kotlin every 6 months or so, KMP every 6 months or so, last time in December. When would you recommend them to take a new look? Is there any big milestone release coming or any big goodies being released anytime soon?
Yep, 1.5 is coming. I can say that it will bring some huge new features for regarding KMM, mostly stability fixes in improvements. But the plan is to moving straight forward to beta, and I think all major versions they are good to check.
Okay, so Johanny, keep in mind that you need to make a pull request upgrading Kotlin to 1.5 soon. So, folks, you have any further questions? Something you would like to ask Kathrin? No, yes, no. Okay, well, Kathrin, thank you so much for being a part of the meetup. I guess if they have any question, they can probably find you on the Slack, the Kotlin Slack channel, and on your Twitter account. And yeah, I think maybe in order to say goodbye, we could bring these three fantastic people back into the screen. And yeah, thank you all for being a part of it, and Daniel, Marc Reichelt, and well, Novatec for coming up with the idea of this meetup. Really appreciate it. We hope we can welcome you at some point, hopefully not so far away in time, in Munich, and invite you to a beer. But yeah, we probably it's not going to happen very time soon, right? Unless the vaccine starts speeding up.
Yeah, and last but not least, thanks to you, Enrique, for organizing this event.
Exactly.
Yeah,
I was about to say that. Thank you, Enrique. As always, you made it a breeze to come on stage virtually. So thanks for that.
Yeah, and thanks.
Always a pleasure to help the community.
Yeah, and thanks also to everyone watching the stream live. I found it really nice that the chat was so active. So thanks to you, listeners.
Okay, folks, then I think it's time to wrap up. 7:53 in Germany. So thank you so much for making the time. And yeah, let's keep connected via Twitter, Slack. As mentioned, folks, I think all the speakers we had today are very easily Googleable and findable. So yeah, let's stay connected and see you on our upcoming meetup in May, which I think is already announced, and we'll have also very interesting people there.
Awesome. Thank you.
Thanks,
Bye.
everyone.
Thank you.
Bye.
Bye-bye.
Bye-bye.